I'll wait till 12 just to give people time if anybody else is coming. Exam 2? Oh, actually, I'm not sure. I think it's might be Wednesday. I would ask, like, someone in the group chat or something. I don't know. Yeah, this exam, there's not too much content like the other exam. The other exam had a lot. This is kind of small amount of content. So basically what you need to know for the upcoming exam, um, so the first couple topics, that's just basically graphing. Like you just need to remember the steps of how the graph with the few new rules in it. It's kind of adding on to what you did for the last exam. And then the inequalities, that is just like a singular topic. You only need to like know that once, but there will definitely probably be at least one or two questions on inequalities. Um, what else? These bottom three, um, those are also graphing, but like exponential. Um, kind of the same steps as the top three topics, but a little different. And then everything else it's just going to be heavy on logarithms, like going from e to log, or going from log to e, or going simplifying logarithms or expanding logarithms. That's what's it's going to be heavy on this. But I would definitely make sure there will be questions. I'm sure he'll give you a blank graph and you'll have to graph something. So make sure you know how to graph these things, and we can go over that. So I can just, you guys can let me know what you rather do. So I can either um, go over each topic like one by one, just like an example of each topic, or if you guys want multiple examples from a singular topic, we can do that. We only have an hour, so we're limited. Okay, so we can go one by one. That's fine.
Yeah, I was gonna say if we can go like top to bottom, just like one example of everything.
Yeah, I can do that. So I have all the classworks here. I'll pull examples from the classworks because honestly, those are the most like, if you're going to study for this test, make sure you basically know how to do every single question on the classwork. It's very helpful. So the domain of rational functions, the domain of rational function is basically if you have, let's say 4x over x minus 2. The domain of this, all you do is set the denominator equal to 0 and you solve. Right? So then your domain would be x cannot equal 2, so it would be negative infinity to 2 union 2 to infinity. That's what the domain is. Just know that your domain, the denominator is set equal to 0 and you solve. And for the arrow notation, I'll go over this. We'll come back to this because I can explain it once we do a graph. So the vertical, horizontal, slant asymptotes, let's see. Let me find that worksheet. Yeah, okay, here it is. So for the vertical asymptotes, you're going to, so vertical, it's going to be setting the denominator equal to 0. So denominator equal to 0. And for horizontal asymptotes, you're going to do the what is it? N over M. So the two coefficients in front, and then slant is the more complicated one where you do the dividing. So like that, the synthetic division. Yeah, that's a D. So let's do a vertical asymptote. It's a D. Denominator equal to 0. So for the first one, what you're first going to do with this is you need to get the denominator simplified enough that you could set it equal to 0. So these x's can cancel and you're left with 1 over x plus 5, right? And then from there, you can set the denominator equal to 0. You get x is equal to -5. So that's your domain. So the domain, so that means your vertical asymptote is going to be x is equal to -5. This is how you write a vertical asymptote. So vertical asymptote is x and horizontal asymptote is y. So, and so your vertical asymptote, is x is equal to -5. What would your horizontal asymptote be? Well, for this, you need to look at your already simplified one, and you do n over m, right? So you get 1, but when I mean n over m, I mean like x to the n over x to the m. So for this one, you have no power on the top, so your n is going to be equal to 0. Let me mute somebody. There we go. Okay. So when you're top, this is going to be x is equal to 0, and that's how you get 1. And in the bottom, x is equal, the m is going to be equal to 1. So that means your n is less than your m, which by rule, this means your horizontal asymptote is equal to 0. So I'll do another example of that because I know it can get kind of complicated. M is 1 because if you have x to the 0, then that's just 1, right? But if you have x to the 1, that's x. X squared is x squared, and so on and so on. So down here, m is going to be equal to 1. So I'll do another example of this. And the top is 0 because so we simplify this. We got rid of the x's right here. And then when we simplified it, you get 1 over, yeah, exactly. X to the 0 is equal to 1. So you got 1 over x plus 5. And if you have 1 on top, your n is going to be equal to 0. If you had x on top, then your n would be also equal to 1 as your m is equal to 1. And that's a different rule. So let me do the second one. So for this one, you need to get the denominator to where you could simplify it. So you can get x plus 7 on top. And then in the bottom, you're going to get x plus 7, x minus 3. And then from here, you can cancel these, and you're just going to get 1 over x minus 3. So now your vertical asymptote is going to be x is equal to 3. Why your horizontal asymptote is going to be, so if you look at this, your n is equal to 0 again, and your m is equal to 1. So n is less than m, so y is equal to 0. Mention it just in case. So basically what Andy is saying that since we canceled these out, it means there is a hole at x is equal to -7. If he doesn't ask for the hole, then you probably don't need to mention it, but if you know it, mention it just in case. It's always good to mention things like that. Yeah, so here are the rules. I should write them out for you. So n is less than m, y is equal to 0 when n is equal to m, you do the coefficients. So if you had, let's see, 15x squared over 3x squared, these two are the same. X squared and x squared are the same, so n is equal to m. So your answer for it would be 15 over 3, which is equal to 5, my bad, which is equal to 5. So that means that in this case, y is equal to 5. So when n is equal to m, you're going to do the coefficient over a coefficient. And then when you have n is greater than m, that means there's no horizontal asymptote. So I'll show you these. So in this case right here, you have your n is less than your m. So therefore y is equal to 0, right? Because n is equal to 1, m is equal to 2. Now for the second one, your n is equal to your m because n is equal to 2, m is equal to 2. That means y is going to be equal to 15 over 3, which is 5. And now for your last one, you have your m, not your m, your n is greater than your m. So that means there's no horizontal asymptote. Just remember that it's always n over m. Is everybody good with those? Yeah, okay, I'll move on to the slant asymptote. So for the slant asymptotes, let me see. Okay, so for slant asymptotes, which we have here, a slant asymptote is, you can only use the slant asymptote when your n is greater than your m, right? So in this case, so you're going to take your denominator, x minus 1, and you're going to divide it into your numerator. So x squared minus x plus 1. Now from here, you need to do synthetic division, which it sometimes it has a slant when n is greater than m. On the test, he should tell you when to find your slant and when not to find your slant. So don't worry more about like when to use your slant, worry about how to find the slant, if that makes sense. So for synthetic division, you change your, right here, you change it to positive. So this becomes just 1 instead of negative 1. You drop all the x's. So this just becomes 1 minus 1 plus 1. You bring this down. So then you have 1 times 1 is 1. Negative 1 minus 1 is 0. And then you do 0 times 1 is 0. So you're going to get 1 here, right? And then you bring down, so this was a 2, so you're going to bring down 1 less than that. So this just becomes 1x, this stays 0, and then this is your remainder. So your answer for this, when you put it all together, is going to be equal to x with a remainder of 1 over x minus 1. Yeah. So you basically, Andy's right, by the way, what he said. But so that means your slant asymptote is going to be y equals to x, and that's where your slant asymptote is. So if you were to graph your slant, this is what this one would look like. So there's your graph, and y equals to x. That would what your slant would look like. And that means if you had a function like this, it could not cross that asymptote, right? So that's basically what the slant is. You just need to do this synthetic division. Okay. So is everybody good with those? No, you do not need to include the remainder for the slant. Okay, so I think it'd be good to do the graphing thing real quick because there will be a question on, they will just say graph this function right here. So there's steps. So step 1 is to look for symmetry, right? So that means we need to plug in f of negative x. So when we plug in f of negative x, we get negative 3x over negative x minus 1, which it does not equal negative f of x, and it also does not equal f of x because we did not get the original. Yeah, I can scroll up. Let me see. It says graph the following. Here, hold on. So the question is to graph the following rational function. We're doing this one right here. So the symmetry, we didn't get the negative f of x and we didn't get the original. So that means there is no symmetry. Now we need to do step 2, which is to find the x-intercept. So for the x-intercept, you set your numerator equal to 0, right? It's to find the x-intercept. So you're going to do 3x equal to 0. You divide by 3 on both sides. You're going to get x is equal to 0. And that'll be your x-intercept. So what this tells you is that along the x-axis, when y is equal to 0, your x is going to be equal to 0, right? So there you have one point there. Yeah. So for the first one, I just plugged in negative x. So I just turned all the x's negative, and so you get negative 3x minus x, like minus 1. And that just like you didn't get your original, and you don't get negative f of x. So basically you have no symmetry. So for this third step is to do your y-intercept, which your y-intercept is just plugging in 0 for x. So you're going to get 3, 0 over 0 minus 1. You're going to get 0 or negative 1, which is just 0. So that means when x is equal to 0, y is also equal to 0. So these ended up being the same point. So if it was negative f of x, that would be the same as, so if your function was f of 4x, negative f of x would be negative 4x, right? But let's say if it was 4x over x plus 1, it would be this is what negative x would be. Just only one negative. This has 2 negatives here, so it is not this one, right? So now that we did step 3, step 4 is to find your asymptotes. So let me erase. So when we're looking for our asymptotes, let's start with the vertical asymptote. So the vertical asymptote, we're going to set the denominator equal to 0 and x is equal to 1. So that's your vertical asymptote. And now your horizontal asymptote. So if n is equal to 1 and m is equal to 1, n is equal to m. So then you're going to say so you get 3 over 1, which is just 3. So y is equal to 3. And here, since n is equal to m, you're not going to have any slant asymptotes. So don't even test for that. So now we can try to graph this. So here, let's do this. And from earlier, we had a point at 0, 0. We had a horizontal asymptote at 3. So like this. This is y equals 3. And then we also had a vertical asymptote at, what was it? 1. So we just need to plot a few more points just to really get the shape of the graph. So let's see what would happen at f of -1. We would get -3 over -2, right? Which is 3 over 2, which is 1.5. So that means at at -1, we're going to have a positive 1.5, which should be right here. Sorry, I'm just plugging in my computer. Okay. So that will give us that we could then tell that our graph would look a little something like this. Here, let me change colors. So that means our graph would look a little something like this. Remember, we cannot cross these asymptotes whatsoever. Now let's test a point on, somewhere over in this space over here. Let's do f of 2. When you do f of 2, you're going to get 6 over 1, which is just 6. So here's 1, here's 2. You're going to get 2, 6. And now let's do f of 3 just to see what happens. When you do that, you're going to get 9 over 2, which is less than 6. By the way, you can just divide in your calculator. So here's 3. Here's this. So that means your graph is going to look like that. So that's what your finished thing would be. Does that make sense for everybody? I'm sure on your test you'd have like a problem pretty similar to this that says just graph. Okay. Let's see what else. So we did the domain asymptotes. Let's do, okay, so let me go back to that so if we had, here's this, and let's say our graph looked like this, then as x approaches, as x approaches infinity, f of x is going to approach, so x is approaching infinity this way, that means f of x is going to approach positive infinity, right? But as x approaches negative infinity, so as x is going this way, f of x is approaching 0. So that's basically what this means right here. You just need to follow the graph. Let's see. So let's go to this classwork now. Where is it? Approaching 0 because if there was a horizontal, yes, if there was a horizontal, it would be approaching that. So let's say we have this horizontal asymptote and your function looks like this. So as x approaches infinity, so as x is going this way, that means that your f of x is getting closer and closer to this horizontal asymptote. So that means f of x would go to the horizontal asymptote, which you would have a number, so like 3 or something. But as let's say your x is approaching negative infinity, so your x is going this way, your f of x is getting closer and closer to negative infinity. It's going down. So that's why f of x equals to negative infinity. And then the last one, it was going to 0 because as x goes to negative infinity, so this way, your f of x is getting closer and closer to 0. And this is the usual function for like something like 2x, because if you plugged in x is equal to 0 in this, you're going to get 2 to the 0, which is 0. So that's why f of x is approaching 0. So now, let's see. So let's see. Let's do one of these. So this one is going to take a lot longer because it's the quadratic formula, but I don't think he'll give you a quadratic formula on the test just because it takes like a really long time. So I'm going to just simplify that one down to, okay. So for this one, if you're asked to solve this, first you're going to move over everything on your right to your left. So this becomes plus 3 is less than equal to 0 or less than 0. And that you're going to want to solve this. So I'll just go ahead and tell you that x is equal to negative 0.64 and x is equal to 4.64 because x plus 0.64 and then x minus 4.64. So when you're solving an inequality, you want to make a chart, so negative 0.64 and then positive 4.64, and you want to test something on each side. So you want to test negative infinity to negative 0.64. You want to test something from negative 0.64 to 4.64, and you want to test something from 4.64 to positive infinity. And you want to see which of them are true, right? So let's say for the first one, you need to plug in something less than negative 6. So you could plug in negative 1, which I'll just tell you will give you positive 2. And you have to refer back to this. So is positive 2 less than 0? No. So this one's out. Let's say for this one, you plug in 0. When you plug in 0, you're going to get 3, or negative 3, my bad. You're going to get negative 3. Oh, by the way, this is -3. -3. So when you plug in 0, you're going to get -3. And is -3 less than 0? Yes, it is. So this counts. This is part of your domain. Now, for the last one, if you plug in 5, you're going to get 2, which is not less than 0. So that one's out. So all you're left with, the only thing that was true was from -0.64 to 4.64. And that's what your answer will be. Your answer will be this. And you can write that as this, or you can write -0.64 is less than x is less than 4.64. And that's how you would write your answer. So x is between -6.4 and positive 4.64. So basically, when you're solving these inequalities, just solve for x and then test points on the left side, the middle, and the right side. Let's see. And so for this one, you just found the x values, but for this one, you would need to do the top and the bottom. So x is equal to 2 and x is equal to 4. You'd plot those on the number line, 2 and 4. You would test the points on each side. Yeah, so whichever one gives you a number less than 0. But for this one, it's a different sign. So you need to look for things that are greater than or equal to 0. So on this side, you're going to get a negative number if you plotted something. In the middle, you're going to get a positive number if you plot something. And here you'd get a negative number. So this is the only place that the numbers are greater than or equal to than 0. So your answer would be x is in between 2 and 4. And then it'd be including 2 because it's in your numerator. So 2 was in the numerator, so this is included. So you could write it as this or like this. This is a bracket because it's including. Is that okay with everybody? Did that make sense? It's including 2 because x is equal to 2 here, x is equal to 4. Remember that anything in your denominator, it cannot actually equal to. So this is why it includes, this is why it does not. Yes, you add the bracket if it's not undefined, so it's including. So that's why it looks like this, because you cannot have actually 4, because your domain for this would be x cannot equal 4. Let's see. Let's go back to, so when you're graphing an exponential function, so like if you have 2 to the x and you need to graph that, all you need to do here is plug in points. So you could plug in 1, you could plug in -1, you could plug in 2, you could plug in -2, and that's how you just graph it. So this would be 2, this would be 1/2, this would be 4, this would be 1/4. And you would literally just graph this and it would look something like this. And that's how you plug in, you graph exponential. So let's see. Let's look at the transformations of exponential functions. So the transformations of exponential functions, let's see. So if you have f of is 3x, if you had, let's say, 3x plus 3, 3x minus 2, and then -3x, 3 minus x, 3x, and then 1/3 3x, and for the last one, 2x. So for each of these, so for this one's a vertical shift up, which means if you started with 1/3, this would then become 1/6 because you're going to add 3 to the y. Now for the next one, this is a horizontal shift to the right? Because if you have a negative, it's actually to the right. If you have a positive, it's to the left. So you have a horizontal shift here. So that means 1/3 would then become, you're going to add 2 to the x because it's going to the right too. So then you would have 3/3. For this one down here, the negative, you're basically, this is a vertical reflection, which means that you are basically going to take the y part and just make it negative. This one is a horizontal reflection, so you do the opposite, so it becomes -1, +3. This is a vertical stretch right here because this is greater than 1. So that means you're going to multiply the y times 3. So this is a vertical stretch, which means 1, 9, because you do 3 times 3. This is a vertical shrink, because this is n is less than 1. So that means you're going to do 1 and then 3 divided by 3, which is just 1. And then for the next one, this over here is a horizontal shrink because m is greater than 1, so it's a horizontal shrink, which is the opposite. So you would have your 1 divided by 2 and then 3 because you're going to divide by that. I know I went fast on that. I'm just trying to go fast, but please stop me if you have any questions. So yeah, 2f would stretch y. Okay. Yeah, I'll keep that up there for a little bit. So basically, let's see. I think, so now we can just start going over the logarithm stuff. Yeah, so I'm sure you'll probably have on the exam, you'll have a graph a rational function like we did earlier, and then he'll probably have a graph an exponential function with the transformations. So he'll probably give you something like 3x and then say graph the transformation of like, let's say, so if the base is negative, and if x is negative, the opposite. So if 3, like f is negative, then it's a vertical reflection and oh, I see what you're saying. Yeah, that's right, Andy. That's what you meant. Yeah. Just remember, if you have negative in front of the whole thing, your y is going to become negative. And if you're negative up here, or like you have this, then this becomes a negative x. A horizontal shrink would be your m is less than 1. So if this was, instead of 3 to the 2x, if it was 3 to the 1/2 x, that's okay. So horizontal shrink, the last one's a horizontal shrink. If you're 2, if like 3 to the 2x, m is greater than 1, so that's a horizontal shrink because you're going to take your x and divide it by whatever you have. So you have 1 and you're going to divide it by 2, and that's why it shrinks. Let me see if I can show you the rules for this. Okay. Okay. You might want to take a picture of this. This is from the textbook. This is something nice to have. This is basically all the rules you need to know. Okay, so let's see. What else we could go over is, does everybody feel comfortable on, yeah, I can put it up again. Where'd it go? Yeah. So is there anything dealing with logarithms you guys don't feel comfortable on? Like, how did you guys just feel lost in it, or did you guys feel okay in it? Okay, they're good for you. I'll go over how to find the domain of a logarithm because that's actually could be kind of complicated. Yeah, make sure you, so let me pull up here's this. If you guys also want to take a picture of this. Yeah, so I'll do an example of finding the domain of a logarithm. So let's say you have g of x is equal to ln x minus 7 squared, and they ask find the domain. What you're going to want to do, so ln is the same thing of log e x minus 7 squared, and then from there you set your inside equal to 0. So x minus 7 squared is greater than 0. That's, you always want to do it like this, because if log of x always has to be greater than 0. X cannot be less than 0. So that's why you set whatever you have in the inside greater than 0, right? So this is what we'll get when we, so x minus 7 squared is the same thing as x minus 7 times x minus 7. You're going to get x equals 7, x equals 7. And then from there, so that now that you got it twice, you need to plot 7, and you need to see what works on the left and the right side. So for negative infinity to 7, and then from 7 to positive infinity. If you plug in 0, and you're plugging the 0 into, you're plugging the 0 into this right here, this right here. So when you plug in 0, you're gonna get 49. So because 0 minus 7 squared, so 0 minus 7 is -7. -7 squared is 49. And then so you check, is 49 greater than 0? Yes, it is. So that works. That's in your domain. Now for the next one, let's plug in 10. 10 minus 7 is 3. 3 squared is 9. So this gives you 9. Is 9 greater than 0? Yes, it is. So that means this is also in your domain. So both these are in your domain. So that means your domain is going to be from -infinity to 7 union 7 to infinity, which you could also write as x cannot be 7. And that's how you do the domain of a logarithm if they ask. They'll also could give you a domain question like this, where log 2 minus x, and find the domain of this. You do the exact same thing, 2 minus x greater than 0, you would solve, so you would get -x greater than -2, divide by negative. You would get x less than +2. You had to change this gets changed because you're dividing by a negative. If you divide by a negative, your sign changes. So then it becomes x is less than 2. And since you only have this is all you have. Your domain is literally just -infinity to 2, because everything less than 2. And that's what your answer would be for that one. Is that okay with everybody? Okay. Let me see what else there is. So, does anybody see anything on there that on this like topic list that they want to go over? Yeah, we can go over expanding and condensing. Let me see. Let me find a. Okay, these are condensing right here. So when you're condensing, you have a long thing and you basically want to make it smaller. So this right here uses product. So this would just become ln of 3x, right? This right here uses product and exponential. So this would become log x to the 5th times y to the 6th. Because your 6 gets brought up, your 5 gets brought up to the x, and then they're adding, so it's multiplying by each other. So let's say you had 5 log b of x minus 6 log b of y. So now that it's a minus in between, you're going to get x to the 5th divided by y to the 6th log b. So that's the difference between the plus and the minus. Now for the last one down there, so this one uses, so you have this part, you have exponential, you have product here, and you have quotient here. So that means that you should probably start with, let's say, the quotient. Let's start with the quotient. You always want to start with, I guess, the smaller area. So for that, you're going to get log 4 of x over y. And then you can now apply the exponential to it, because this 1/3 gets applied to the whole thing. And then now they're being added by this part over here, so you can then multiply. So then this 2 also comes up there. So you have log 4 of x over y to the 1/3 multiplied by x plus 1 squared. And then this, when anything is to the 1/3, so x to the y to the 1/3 is the same thing as 3 square root of x over y. And I think he'll want you to write it like this. Don't leave it as a fraction, write it like this. Yeah, just, I think always just write it in the radical form, because you never know. Like, this is like the actual simplification of it. Let's see. Now, let's say you had log b over x squared y over z squared, and they want you to expand this. When you're going to expand it, first look at, so first you have something dividing, right? So you're going to do log b of x squared y minus log b of z squared, right? Because these two are dividing. Now you can go another step further, and because the x squared and the y are multiplying, you then could do log b of x squared plus log b of y minus log b of z squared. And last, you can do exponential. So you got 2 log b of x plus log b of y minus 2 log b of z. So when you're expanding something, I would just try to do quotient first, then do product, and lastly do exponential. It's not always going to work out in this rule, but it might work most of the time. So let's see. Let's say you had ln square root of e to the x. When you're expanding this one you want to do the see what I mean? It doesn't work every time. So this one you'll want to do ln of e to the x to the 1/2, because this is the same thing as e to the x to the 1/2. And then now you can apply exponential rules. So you have 1/2 ln of e x. Now these are multiplied by each other, so you can do 1/2 ln of e plus 1/2 ln of x. Now, you need to remember that anything ln of e, it cancels out, right? So you are left with just 1/2 plus ln of x over 2. That's what you're left with. Because ln of e cancels, because ln of e is base e to the e, which just cancels. Is everyone okay with that? Okay, so let's see. Okay, good. I'll put this in the chat real quick. So on YouTube, the guy, I put his name, Organic Chem Tutor. He has a lot of really good examples of things like this. So if you are like, you feel very comfortable with the worksheets and everything, and you need more practice, go look up YouTube videos and do it. Like, they'll give you the problem, pause it, do it yourself, and then they'll do it after you. That's a good way to study. So let's see. Does anybody have anything else on this topic list that they need help with? The change of base? Okay. So when we're doing change of base, let's see. Okay. Change of base is just doing your log 17 over log 6. This is, so basically you're just doing like this one down here would be log 400 over log pi. That's what change of base is. And that's just a way to help you like get an actual numerical answer. So when you put this in your calculator, you're going to want to put log of 17, and then you get that, and you're going to want to do log of 16 or log of 6, you get that number, and then you divide the two. You cannot do this. You cannot do this and then do 17 divided by 6, and you cannot do this. No, that is wrong. You cannot do that. You'll get a different number. So you actually have to go in your calculator and do the log button. So log of 17, you get your number, and then you do log of 6, you get your number, and then you take that number and divide the two, and that's where you'll get your full number. Let's see. Okay, well, we can do one of these two. These are actually important to do. So for these, I'll do the first example. So if you have 3 to the 2x plus 1, there's a rule that if you have the same base, so this needs to be the same base, so you can turn this to 3 to the third. So you now have 3 to the third. They're the same base, so you can then just set these equal to each other. And you're going to get x is equal to 1. The same goes for this one. You can change these to 2 to the third 1 minus x is equal to 2 to the second x plus 2, and then you would set 3 1 minus x equal to 2 x plus 2, and you would solve for that. You're going to get x is equal to negative 1/5, by the way. Let's see what else there is. Here's this. Some of these things, okay, these are necessary down here. So if you guys want to take a picture of these. This is just talking about how if you had, let's say, log of, or 7 log of 7 to the 23rd, you could cancel out this, and you're going to get x is equal to 23. That's with the rule right here. And this rule right here, this is when I was talking about ln of e to the x, the ln and e cancel, so you just get x is equal to x. Same with e to the ln of x, these will cancel, and you're just going to get x equal to x. We did all those. Writing these in exponential form, this might be useful. So there's two rules, and it's that y equal to log b of x, and then by is equal to x. So here you have, this is y, this is b, and then this is x. So then this, you would do 9y, or 9 squared equal to x, because you have by. Now here's your b, this is your x, and this is your y. So then you would have 5y is equal to 25. Okay. So does anybody have any, for those, you do not need to solve for y. Like these right here, you don't need to solve for y. But in these down here, when they ask you to evaluate the following expressions, then you need to solve. These are just write the following. Writing, you don't solve, but when they say evaluate, you need to solve. So for these down here, if you have the first one, you need to remember that. So let me write those again. Y log b of x, and then by equal to x. So this is your b, this is your x. So 7y equal to 49. You need to assume that all these are equal to y. So 7y equal to 49, y is going to be equal to 2, because 7 squared is 49. Now for the second one, this is your b, this is your x. So you need to remember that 6 to y is equal to square root of 6. Y is going to be equal to 1/2, because 6 to the 1/2 is equal to square root of 6. So when they say evaluate, you need to solve. When they just say write, don't solve. Okay, so we're running low on time. You guys can always email me if you have any questions over the weekend. I'm putting my email again in the chat. Okay. Feel free, you guys can more than welcome to email me. I'll try to answer anything. This is recorded too, and I'll get Professor Reyes to post it. Does anybody have any last minute questions before I end this? The classwork, mostly based off the classworks. You guys are welcome. You can feel free to email me anytime. Bye, guys.